Hi everybody, I wanted to give you a chance to do a little bit of review for our test this week, and I want to start at the very beginning of the year. We started talking about inferences and observations. Observations are things that we can see with our senses. So in this case, we're looking at an airplane, or I see a white streak in the sky. That's an observation. The cloud, these things, I see some green light in the sky. I see stars. I see a boardwalk. Those are all things that I can see. Now, this I might say that's from an airplane. It's an airplane contrail. Or these green lights are from some atmospheric disturbance like a solar flare. I can make guesses, but I don't know for sure. That's what an inference is. We're using our observations to make a guess. When we look at longitude and latitude, which is what we did next, the 0 points, our reference points, are here, the equator and the prime meridian. Remember, latitude lines run this way. They measure north or south of the equator, and if, let's say, I'm at the Tropic of Cancer, that's 23.5 degrees north latitude. It's 23.5 degrees above the equator. So that's where those degrees come from. If I'm at the North Pole, I'd be at 90 degrees north of the equator. The the longitude lines right here, here is our 0 point for longitude, that they run this way, but they measure east and west of this prime meridian, which is 0. The highest longitude you can have is 180 degrees. If you are looking at this, again, always whenever you have a map, make sure that you know which compass direction is which. Never eat, oops, sorry for my writing, never eat shredded wheat, never eat shredded wheat, or some mnemonic, never eat soggy mushroom, soggy worms, whatever it is. You want to have some way to remember that, because when you get to this, if let's say I'm at 10 degrees on this line, where am I in relationship to my zeros? So if this line is running this way, where am I in relationship to this 0 line? Well, I am north of it. Where am I if I'm down here at 20 degrees? Where am I in relationship to the 0 line that is parallel to that? I'm at 20 degrees south. If this is my 0 line, my longitude line, I'm going to be, and I'm right here on the number 5, I had to go to the east, so that would be my reference line, my longitude, my prime meridian would be my reference, and if I go this way, then I'm west. Take a second, don't look at the numbers over here, and just see if you can get what ones are what. See if you can figure out what the longitudes and latitudes are for a little bit of practice. If you can do that, you're doing well with latitude and longitude. The thing that our observations, what we can observe about latitude and longitude, is that we can see from where we are, we can look up to the Polaris, whatever it is above the horizon, that angle is equal to our latitude. So our latitude north of the equator is what is equal to the altitude of Polaris. They're always equal. You cannot see Polaris in the southern hemisphere. It's below the horizon because the equator is at 0. If you go below that, then you're in negative latitudes, and so Polaris would be below the horizon. When you're at the North Pole, Polaris is directly over your head. When you're at the equator, it's right here at the horizon. And wherever we are in between, that's where it is. So if you're in Syracuse or Utica or Ithaca, it's around 42 degrees, 42, 43 degrees, because that's our latitude. Longitude allows us to figure out the time, using solar time, we can figure out our latitude. If there's two places that are on the same longitude, we have the same time. They have the same solar time. So the time zone is going to be the same. We spin 15 degrees per hour. That's an important number to remember, 15 degrees per hour. And so if 1 hour goes by, then you've moved 15 degrees this way. So remember, if your time compared to the prime meridian is less, then you're west. So if, let's say that it's 2 p.m. where you are, and it's 5 p.m. at the prime meridian. We know that there are how many hours difference here? 3 hours difference. 3 times 15 degrees gives us 45 degrees, because we move 15 degrees for every 1 hour that of time difference between the prime meridian and wherever we are, and our time is less, so we're west. So we would be at 45 degrees west longitude. If this was the time at 0 prime meridian and this was our time. If your time increased, then you're east. Let's say it was 7 p.m. where you were instead of 2 p.m. If it was 7 p.m., that's 2 hours. Our time increased from the prime meridian. That would be 30 degrees. So we would be 30 degrees to the east. That's how you can use the idea of time to help us figure out what your latitude is. The time zones are about 15 degrees apart because we move 15 degrees an hour. And if we go this way, the time is earlier. If you go that way, it's later. Just remember, California is before us, and Central Time is before us. So as you go to the west, your time gets less. Then we got into topographic maps. And if we look at this map, this is a good example of all the things that we can see with topographic maps. Where these lines are close together, it's a steep hill. Where they're further apart, it's more gradual slope. Gradient and slope are the same, and I'll talk a little bit about gradient again to remind you. Remember, if there's circles going in, concentric circles like a bullseye, that means you're going up over a hill. That's a hill right there. That's a hill. If you have these little harsher marks, that means that's a depression, so you're going downhill. So that's what those little dashed marks around the contour lines are. They're called harsher marks. Excuse me. And when we look at this, you need to figure out lots of times what the contour interval is. Remember, the ocean's always 0, and you can just sort of guess. Does it go up by 10, 10, 20, 30, 40, 50? No. 20, 40, 60, 80, 100. Yes, it goes up by 20 meters each time. Lots of times the contour interval is right on here. So that's one thing. The contour lines, when they cross a stream, they always point uphill. They point the opposite way the river's flowing. This water is flowing downhill. We see this is 100. I know the ocean's at 0, so the water has to be flowing this way. Also, these point uphill. They point the opposite direction the river's flowing. The other thing, if you want to try and find the elevation at the highest point, let's say it's this point right here is the highest point. The elevation there, remember, as you go up and over a mountain, mountains are never flat at the top. So if this was elevation of 200, this was an elevation of 220, the next contour line would be 240. But this never gets to 240 because there's no contour line in there. So it's just one less than that next contour line. So it's just a little bit less. This would have been 220. This is 240. So it would be one less than that, so it would be 239. So that's the elevation of the highest point of that hill. Z is at 220. It's right on that line. And all these points have the same elevation. This is just a railroad, just a standard thing for what a railroad would look like. And I think that pretty much tells you what's going on with this map. If I had to ask you, make a guess as to what you would do if you walked from X all the way to Y. Just think about that for a second. What would you see, or what would you experience in terms of elevation change as you walk from X to Y? I'll show you what the profile might look like. You're going to go up a hill, up over 300, and then you're going to go down, down, down into this stream valley where Mill River is. You're going to come back up again, but not as high as the other side. You get to right about here, you're down here, you're going up, 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 and over the top of that hill again, and down. So this goes up, down into this river valley, back up, over this other little hill here and down. But this didn't get up to 300 because it would have, or even up to 200. So this is up and down and up. You're going to have to do that on the test. You're going to have to look at a profile and try and or look at a map and try and figure out what the profile looks like. And you have to think about that. If you're going around concentric circles, you're going that's the highest point. So you're going up and over. Then you're going from 300 down to 200 down to 100. So I know I'm going downhill. And then this, I know this is a stream, so it's going to go down into a stream valley and start coming back up. And then another hill right here. Sorry about my voice. I don't know what happened. I've been talking too much today. This, our gradient, is our change in your field value. That would be your elevation change. That's sort of like your y, the y value. So remember on an axis, a graph, you have your y over your x, your rise over your run. That's your gradient. Slope is rise over run. It's y, change in y over change in x. This is your y, this is your x. So how much did this drop? It dropped from 250 meters to 100 meters. That's 250 minus 100 is 150. And then the distance from here to here is 10 kilometers. So 10 kilometers. So you take 150 divided by 10 gives you 15 meters per kilometer. You take those, make sure you keep your meters and your kilometers. Keep the units when you're doing these, because then it'll be easy for you to find out what the actual overall units are. This would mean if I walked for just 1 kilometer, I would drop 15 meters. So here I walked 10 kilometers, so I dropped 150 meters. So each kilometer I dropped, I would drop 15, sorry, each kilometer I walked, I dropped 15 meters. So these are the sort of the key points. If you have any questions, feel free to ask me during the study hall or watch it again and see if it makes any more sense. Go back to the other videos if you want to review and spend some time looking over this stuff. Good luck reviewing. If you have any questions, I will be around during school to answer them. Good luck. Take care.